Hello, AP Physics 1, it's Mr. Ng explaining number 2 out of your energy review packet. Here you go, let's just get into it. It says that a force F at an angle theta, some sort of angle above the horizontal, is used to pull a heavy briefcase with a weight of mg, a distance of d, along a level floor at a constant velocity, and there is a friction coefficient. So what is the work done? So I think the biggest clue here is that it's at constant velocity. So that lets us set up our free body diagram pretty easily. So let me explain. So here, this question is about two big ideas. Number one, work is equal to force times distance. And number two, it wants to remind you about free body diagrams. So here, let's draw that free body diagram. So here we have a briefcase. It goes off F, and there's a theta. I'm going to put this into a dotted line because this is a component force. If you remember, this component is going to be F cosine theta, right? That's the component, right? If it's along the horizontal, we do cosine theta. Fine. And of course, we do have mg, and that's going to be the same magnitude as the normal force because it's not moving up and down on the floor. So that means this, the friction, most of you would do friction coefficient N or friction coefficient mg, but you could also make it equal to F cosine theta. How do we know this? Because this thing is traveling at a constant velocity. That means it's going through a dynamic equilibrium, meaning the magnitude here, the magnitude in front and the magnitude in back should be the same size. So here, that means the force of friction is negative F cosine theta. And work is that times the distance, so the work is equal to the force of friction times d. And we already know that the friction is negative F cosine theta. Multiply that by d. So there you go. That's your answer.